forces. Okay, physical science time. We're going to first talk about the definitions of force and weight. What's the equation for force? I'm going to label this just forces because that's pretty much true. Tide. Force. Yeah, so F net force with an arrow over it. What's the arrow over it remind us of? It doesn't remind us of acceleration, but yeah, it means it has direction. We call it a what kind of quantity? Vector quantity. F net equals m. Does m get a little arrow over it? No, because it does not have direction. Mass is just mass. Times a with an arrow over it. F net equals ma. Your book expresses that as a equals F net over m. We're going to talk about in a second why that is also true, but this is the equation for force. Rather, it's the equation for net force. What is the equation for weight? Aaron.
Weight.
Is weight a vector quantity? Yeah, weight is, because remember, weight is the force of gravity acting on you. It's always down. Well, that's how we define down, is which way gravity is acting, but it is a direction. So weight equals mg, and g is a vector quantity, and g, remember, stands for specifically, remember, these things are the same because weight is a force.
It doesn't really stand.
Write that down somewhere. Weight is a force. Write that down somewhere. Because so these two things are they're not the exact same thing, but they are related. Weight is a force. Mass is mass. Those two things are the exact same. And then how are these two related? Well, this is just any acceleration, and this one is acceleration due to gravity. And this quantity is a known value on Earth's surface. What is it? You have to have this memorized.
Gravity.
Yeah, but it has a number too. What is it, Aaron? 9.81
meters per second squared.
meters per second squared. Good. You have to have that memorized.
Equals acceleration with gravity.
Acceleration due to gravity. So like, here's a very basic example. I can whip this across the room, and it will accelerate. And if I drop it, that's accelerating due to gravity. Remember, acceleration is any change in motion. So if I whip it across the room, that's an acceleration, not entirely due to gravity. Part of that flight is due to gravity. But if I just drop it, that's acceleration entirely due to gravity. And so it'll accelerate this rate if I just drop it. Anyway, the next one says, calculate the force acting on an object with a mass of 11.3 kilograms and which is accelerating at 2.1. This says meters per second per second. That is the same thing as meters per second squared. The reason I wrote it like that is because that platform does not allow me to write exponents, so I always write it as that on the board. But you can write it as meters per second squared, or you can write it as meters per second per second. They mean the same thing. How do we do this one? Tell me the first step.
Write out your equation.
Tell me the equation to write out.
F net equals
MA.
But you need
Those get arrows. Yep. Next step. Gunnar, what do I do next? What's the next step in general? I'm not asking you to say the next step, just what is the next step in general for equations?
Put in your number.
Yeah, we call that, we have a special name. Substitute, things. Ethan, tell me what to substitute here. Tell me exactly what to write.
We substitute mass.
Tell me exactly what to write, though, okay, on the board.
F equals 11.3 kilograms.
Okay. I'm going to put F net equals 11.3 kilograms. I'm going to put this in parentheses. 2.1 meters per second squared. It has to be squared. Why does this have to be meters per second squared?
Because it's meters per second times. Because it's acceleration.
It's acceleration. It is meters per second per second. It's how much the velocity is changing per second. So if we just put meters per second, that's velocity, and that's not what we're looking for. It's meters per second squared. And remember, I'm going to carry the F net down. Now what do? What's the answer, Emma? What's this step called first, Emma? Yeah, multiply then. I call it a solution, right? I'm solving it. And what is the answer? 23 point. I'm just going to put 23.7, and then so 11.3 times 2.1 is 23.7. Then I'm done, right?
No.
No. Good. Thank you. Also, kilograms times meter per second squared is. It is this. But we have an abbreviation for this whole lump. Remember this? Someone should be writing this down. It is this. It is kilograms times meters per second squared. But we have an abbreviation for this whole lump, which is, say it, newtons. Yeah, these are the same thing. These two things mean the same thing. We just abbreviate this lump as newtons. Okay? Questions about how to do this? You have to, every single time, write the equation, substitute, and solve. Make sure you have units with your substitution. Questions about that? Let's back up to these equations real quick. I'm going to do a different color here. We're going to talk a little bit about manipulation. So let's have a little side note in our notes called manipulation station. Let's call it equation manipulation station. Write it in. What does it mean to manipulate something? Make it do what you want to do, yeah. If you're manipulating your friends into trying to take you to Arby's even though they want to go to Subway, you might say things like, Subway is disgusting, I hate your guts, I hate everyone who goes to Subway. You don't really believe those things, but you're trying to manipulate it.
I got one.
Okay, let's hear it.
I would say, if we don't go to Arby's, I'm going to go to your house.
Okay, yeah, so that would manipulate people. That would be a way of changing the outcome. That's what manipulate means. In fact, this word manipulation is related to the Spanish word manos, which comes from the Latin. They both come from the Latin, but the Spanish word manos means hands. Yeah, it's manipulate means to use your hands to change something. So like if I manipulate my little ticket, have Mr. Lovercheck cover my class, I'm manipulating. I'm using my hands to change it. So it's related to that word. But what we're really doing here, since we're manipulating an equation, is we're changing the outcome. We're changing probably what, since it's math?
The answer.
Yeah, we're changing the answer from the variable we're normally given it in. I'm just going to put f equals ma for this because it'll make it easier so I have to write less. What are we solving for here? What do we call the isolated variable? What's isolated mean?
It has to stay in one spot.
No. Isolated means it's...
Separated.
Yeah, separated. It's by itself. What's the isolated variable here for which we are solving? F. But what if the question wasn't calculate the force acting an object with a mass of blah, 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 and an acceleration of blah, blah, blah? What if it was calculate the acceleration of an object with mass whatever and force whatever? Well, now we can't do that. We can't solve. This is set up to solve for force. So what do we have to do? If we're trying to find acceleration instead, we use the vocab word that I just taught you. We're going to do what to the equation? We're going to manipulate the equation. In this case, if we're trying to solve for A, algebra friends, what do we have to do to get A by itself?
You have to
Divide by m. We're going to divide both sides by m. But look! The m's, yeah, they reduce. They divide to 1, right? They cancel. Remember, Mr. Slade doesn't like that, and I don't really like that either. But we could say they reduce to 1. So now we have, pull everything else down, f over m equals a. That's fine. Can you do this? I think so. This is very basic algebra, but watch where it gets a little bit tricky. Let's do this one. I'm going to have another manipulation here. Let's have one where, example 2. Let's say we have v equals d over t. What's this equation for?
Velocity.
This one, without the arrow, is speed. Please pay attention to this. People mess this up so often. What if I want to find time by itself? I'm going to give you a little cheat code. What if I want to find time by itself?
You multiply by distance.
Yeah, okay, so that's the trouble. Can we multiply by distance on both sides? Let's try it out. Let's do that. What do we end up with if we do that? We get dv equals d squared over t. Is that what we wanted? No. So let's not multiply by d on both sides. What else can we do? Let's try another way. Don't write any of these down because these are all going to be bad. Okay, hey, that's actually the right way. So yeah, let's make both into the reciprocal. That's fine. And now multiply d over. That's fine. This is not the way I like to do it, but this is fine. This is the right answer. You can use the reciprocal of both to get t on top. You know what I mean by on top. I mean in the numerator. I mean in the numerator. You can use the reciprocal to get t on top. Or here, the point is, let me tell you this. Write this down, please. Get the isolated variable, or the variable to be isolated. Variable to be isolated. Get the one you want. That's what I'm saying. Get the one that you want. The one you want by itself in the numerator first. Don't forget this. It is so much easier if you put the one you want in the numerator first. The way that Taylor's suggestion and the way that it's written now is fine. That is not the way I prefer it, but that does work. Here's what I would like to see. Here's what you should do, in my opinion. Multiply both sides by t. And some will come like, well, Mr. Kern, that doesn't get t by itself. And you're right, it doesn't get t by itself, but what does it do?
Gets the right answer.
No, it gets it in the numerator. It gets in the numerator. So now our t's reduce out, and we're left with tv equals d. And now we can divide both sides by v, giving us t equals d over v. Either way you do it, make it the reciprocal and then finish up, or get the isolated variable in the numerator and then finish up. Either way you do it, it's going to take 2 steps. The manipulation takes 2 steps. Fate.
To make it easier, you can also use the associative property for the force over mass times acceleration.
Yeah, I don't know.
For this one?
Flip it. Yes.
This one, flip it?
Yeah, flip it so A equals force over mass.
But it does already.
It doesn't really matter where your variable is.
And this one's easier because it's already one step. In my opinion, if you want to do it that way, that is fine. I think what you're saying is probably right, but this is the way I prefer to see it. I just like to see the manipulation for ones like this, and then I need to see it get on top, the numerator, and then to finish the manipulation. Where does all this happen? Like at what process of this, at what process of our science way of solving linear equations do we do this? Well, let me tell you. What was step 1 of science way of solving? Yeah, raw equation. Write this down again, please, because it's very clear to me from looking at your test that not everyone is good at this yet. Step 1 was raw equation. What's step 2? Uh-oh. Substitute. Give me a second here, Fate. Substitute. What's step 3? Solve. But guess what? There's a step 1.5. Why would I not just call it 1, 2, 3, and 4? Step 1.5 is manipulate. You do this before substitute. Always. I'm going to write this in redder, meaner, hell-colored color. Always manipulate before substitution. Always. Always, always, always. You'll mess yourself up. I don't want to see you put in numbers and then try to change them around. You'll mess yourself up. Always manipulate before substitution. Why did I make it 1.5? Why can't we just have 1, 2, 3, 4? Well, someone give me an answer.
Because not all the time.
Yeah, exactly. We don't always need to manipulate it. If manipulation is necessary, if you have to manipulate, do it before you substitute. Oops, I forgot to do the picture-in-picture, sorry. If manipulation is necessary, do it before you substitute, but it's not always necessary. So I call it step 1.5. This worksheet, that you're not going to work on right now, is all about this. It gives you some just plain old equations and you have to manipulate them. It says like, here's an equation, volume for instance, solve for length. When it says solve for length, what are you going to try to get length to do? Be
Manipulate.
you have to manipulate the equation to get length to be by itself. Yeah, you need to isolate the variable you're looking for. That's this worksheet. So you're going to get that. This is very brief. You should already be good at this. It's just algebra. But you will get a worksheet about it. Next, you'll also have a worksheet about... What's this worksheet say? Can anyone read it?
F equals MA worksheet.
Yeah, this is all problems for you to get practice doing what you need to do for this lesson. Did we talk about Newton's third law yesterday? We wrote it down, but we didn't actually get time to discuss it, right? No.
Every action has an equal and opposite.
Yeah, every action has an equal and opposite reaction. Okay, so hey, we're going to switch to conceptual notes here for a second. So please have your notes out. I mean, keep your notes out. Hopefully you're done with this, because I'm done with it. Thanks, Murph. Okay, check it out. So we're gonna do a little bit of work with Newton's second and third law. Remember that we can summarize Newton's second law as F equals ma. What are some examples of forces? What are some things that cause forces to act? Let's list some forces over here in the corner with orange that no one can read on the video. Push, okay. Pull, okay. We're really getting spiced up.
Stomp.
Throw.
Stomp down.
Throw.
Stomp.
No, give me some other like natural forces.
Punch.
Gravity's one. Gabe, I'll count that as gravity.
Punch.
No.
What kind of force is a wave? Like the tide.
Oh, a wave?
Yeah.
The tide? Like, I would just call it the push force of water probably, but that's a good suggestion. Of course, Of course, the waves are caused by, the tidal waves are caused by gravitational forces between the Earth and the moon. Let's talk about, I'm just going to tell you some more because we're running out of time. Magnetism.
So if we didn't have a moon, we wouldn't have waves?
We would have waves, we would not probably have tidal waves because we aren't tidally locked in else. Yeah. Push, pull, gravity, magnetism, electricity, friction, which some people spell with two I's right here by accident just now. I'm going to leave it because I'm a fallible mortal just like you. Frictione, friction. Let's think of some other ones.
Punch!
Punch is not. That's still a push force. We're talking about in relating to physics. We're talking about these are the physics forces. Physical. There are others. There's the strong nuclear.
But it's a strong nuclear.
We will talk more about that later. Weak nuclear.
What about a
Tension?
site nuclear?
Ooh, very good. Tension force, spring force. There are all kinds of forces. But all of them do what? Unbalanced forces always cause.
An object to change in motion.
Thank you. Excellent job, Hunter. I'm going to write that down. We're all going to write it down. We've heard it before, but we're all going to try. Unbalanced forces, please stop talking. Unbalanced forces cause a change in motion. What do we call a change in motion? This whole thing can be abbreviated as what?
Inertia. I don't know. Acceleration.
Unbalanced forces cause a change in motion. Let's talk specifically now about... Yes, quickly.
In geometry, we're using it too, so
Oh, nice. Good. We are going to very quickly run out of time. The rest of the stuff that is in your... There's one thing I want to get that we... So, there are 3 more things I would have talked about if there were time. 2 of them we talked about last year in 8th grade science. In fact, I talked about this year in 8th grade science. I will post the 8th grade science video in your Google Classroom so you can watch that one to get your conception. It's also in your book. Raise your hand if you've read your book. You have to read your book to do a good job on this test. The other thing I want to talk about is projectile motion. So let's real quick talk about projectile motion. Projectile motion is when an object follows usually a parabolic path and it's acted on by gravity. So here's an object and it follows this parabolic path. Here's an example of projectile motion, Fate. That was okay, I'm sorry for hitting you in the eye with Jolly Rancher. This red Jolly Rancher went from my hand, which looks like that, to Fate's eyeball, which looks like that. And Fate has a runny nose, so he has a really red little... Okay, so the Jolly Rancher followed a parabolic path because it had a horizontal component, X component, of motion caused by my push force, and it also had a vertical component of motion, the Y component of motion, caused by gravity. And so it follows this parabolic path. You'll need to read more about this in your book, but basically one thing you need to know is right here, while gravity is still acting on it, its Y component equals 0. So the whole way up, it's accelerating down. There's acceleration in the Y, but no acceleration in the X. It has a velocity in the X. It is moving forward, but it's not accelerating forward. Whereas up and down, the whole way that it's going up, it's slowing down its upward go. And the whole way that it's going down, it's speeding up its downward go because gravity is always acting down. Gravity always acts down. So right here, while it's still moving up, gravity is pulling it down. So it's slowing down. And right here, where it's already moving down, gravity pulls it down harder, and it's going to speed up.
Wait, so where is the fastest moment? Right before it hits the ground?
Yep. Yes, exactly. And we'll talk more about that in energy, but you're exactly right. It has the most kinetic energy right before it hits, in this case, Face's eyeball. Do you have questions about any of this? Listen to me very carefully. Look at me so I can tell you're listening. You must read your book to get the missing information here. We will talk more about it as we go over your chapter review, but this discussion is like, we didn't have enough time, so you're only going to get a D-level understanding of chapter 3 if you... That's not bueno. Yeah, read your book, and we will talk about it more on Monday.